Hello, this is a demo of test assignments at the architect position in one of the company. So here in the original task we need to develop a social network site where site will be used by a couple users. Here we have a use case for a user would like to see homepage with some users data. Also, users need to be need to have different access rights. This is a data need to be saved as users data. Then we have different sections for different access levels. We have a validation. We have different additional behavior when we would like to delete a data, like confirmation or like offline access. Also, we need to propose architecture for the probably front end and back end applications hosted on Azure and different DevOps practices. From a security point of view, we need to expose only one front end and back end endpoint. All resources will be in a private network. Each API should be scalable in terms of scale out and scale up. Then we need to propose basically two solutions. The first one is a draft architecture for the MVP with like little budget. Second solution is highly available application, fully scalable on a couple domains with pretty nice, basically without any limitations. Also, we need to propose different DevOps practices for branching, for the project structure, for infrastructure as code, and for CI/CD. Basically, that's it about the task. Here I'm going to propose a solution. So we're building a social network website. Probably it will have different applications for a front end and for the API. From the data usage point of view, we already know that it's not a real-time data. It should be highly scalable. It should be a couple stateless web apps, probably. We also able to use workers for delayed data processing. We can denormalize data, and in order to have a high availability and all of this beauty. Then I will show you two projects. First one is an MVP, just a proof of concept, and second version 2 is a highly scalable social network website. Let's go with the first one. So MVP could consist of basically two app services, one for front end, other for a back end, plus we need a SQL database. A simple picture would be something like that. I will go to drawing board. So we have a user opens an Azure website app service with a website hosted of the minified JS and CSS. Then this single web app goes to the other app service, which has an HTTP endpoints, which has some kind of identity management probably built in. Then as soon as it's already a social network website, we probably need to think about some kind of in-memory caching of the data saved in a single instance of the SQL database. And the data table is probably something what is described right here. Title, description, creation, date, and user. Basically, that's it for a simple and MVP solution. Probably we can start with something like this. But for a version 2, we probably need to think about something a little bit complicated. So for the version 2, we definitely need Azure storage, and our front end could be hosted from the CDN instead of app service. Then we definitely need a load balancer in the front of our API. We need separated identity service. Then I propose to split application API services responsible for just only read data, other app service for mutate data, and couple applications hosted as workers in order to process data. Then we need to save everything in a SQL database, plus not only data, plus the event stream for the data mutations. For async communication, I propose to use Azure Service Bus with a couple topics in it, and for the hot data, probably would be nice to use Redis cache. General picture might look like this. Let's go to details. This is our version 2 blueprint. So we have same user, opens our modified single page application, but right now it's hosted in the Azure CDN. From Azure storage, we could distribute our single page application over different locations, for example, or different service with a content delivery network. Then single application app communicates with the two different services. One service for the read data and other service for the data manipulation or mutate operations like create, update, and delete actions. So let's imagine, let's go with the read operations first. We have a user opening our single application, then single application goes to load balancer, and load balancer navigates to one or more read API services. Here will be hosted only get endpoints, and we always read data from in-memory cache of the specific app service instance. So all read operations are executed only from in-memory cache of the same service. It allows us to have immediate response of the data asked by the user. If we're talking about data mutation, then single application goes to the different API, different app service in order to post, put, or delete users' data. With, let's imagine that we have like data creation action, so we need to execute a post action. So this mutate API service will do two things. First, it will write data to the mutation log or event stream, and then it will send a message into Azure Service Bus to the mutate data topic. That's it. When we would like to create something, we basically schedule an operation to be executed later. Then we have a couple workers. First one is responsible for reading events or subscribing to them to the mutate data topic in order to read an event from the mutate log and place data into the read snapshot. Read snapshot in this case is exactly same set of data. So this is a users table with a title, description, and all the things. So it's a delayed operation executed later by the mutate worker by the event in the data in the event bus mutate data topic in order to process a mutate log into read snapshot. That's it. Now, when this operation is done, we probably could set another one event into populate Redis as our hot data storage for then to be consumed by the read API services. So when we finish the operation to creating our piece of data in the SQL database, we can send another one message into different topic. For example, to populate Redis database. For that, we have another one worker responsible listening these exactly messages in order to get the latest modified piece of data and then push it into the Redis cache. Probably having single instance of a Redis cache is enough here because it will be hot, already denormalized, prepared for read operations, pieces of data. When this operation done, we need to inform our read services that there is new or modified data and the in-memory caches of all instances of read API services need to be updated with a new modified piece of data and placed into the in-memory cache for them to display later for user. For that, we also can have another one topic in our event bus. So each read API service register or subscribes to the message into another one topic, saying that when your message arrived here, you need to update your in-memory cache from data from the Redis database. Basically, that's it for this two different type of operations, one to read and one to write data flows. In order to see that our application works and nothing has happened, the first version probably could go with application insights into API service instance. In the distributed version of that application, together with in-app application insight instances, we need to have centralized data log solution. So each of the moving parts like mutate or read services or workers could write all the logs into centralized logging system. Basically, that's it for the solution for the version 2. Then we can talk about, so this is 2 versions of our application. We can talk about code practices for developing the application. Probably here, basic requirements for our front end. It should produce any minified JS or CSS. For that, any kind of popular framework could be used or library could be used, like React.js or Angular. The only one required, we need a minified version to be hosted in our CDN. Then at the front end, we need to have a state management in order to handle a situation where we need to delay data update procedure. For example, if a user has no internet connection, we need to save the modifications in the front-end state in order to proceed the modifications later. So state management is required for the front-end. Then we probably would like to have some single-page application behavior where we change applications without full-page load. And as soon as we already know that we are going to validate data, then validation also should be part of the front-end framework together with an API. For the backend, it should be developed with a native REST support, with a server-side validation, and with native data access library for the SQL database and for the Redis, and publish subscribe behavior for the Azure Service Bus. As soon as we know we're going to scale, then stateless services need to be easily scalable in a horizontal way in order to add new instances. Our workers need to be deployed to Azure. It should have sophisticated logging capabilities in order to write all the actions performed by the workers. It also should have event bus support. Plus, it should be possible to scale workers horizontally. For the development practices, I propose to have at least 3 branches, or at least 3 main branches: main, test, and prod. Use Git flow in order to create a feature branches, and then the code from the feature branches travels over the main branches. For the deployment, it's also nice to have at least 3 environments like dev, TST, and production. Then the code flow between branches and environments could be presented like that. We have a code in 3. Let's go here. We have code in 3 branches. Then as soon as any type of modification of a source code via pull request arrived to the main branch, the main could be built automatically and auto-deployed to dev. Then when a merge request with a set of features go to test, it should be possible to auto-deploy on merge and also execute all set of tests like functional tests and performance tests against the test code deployed to the test environment. When this is done, we create a PR to the prod with a list of features. Prod usually should be built manually and should be deployed manually. In order to avoid any type of data consuming delays, I propose to deploy into Azure hidden slots of the corresponding web apps, and then just switch slots when we are ready with the deployed version. Then on prod, we also could, on a hosting terms, we definitely need to have a dedicated service. Plus, we need to turn on auto scaling in order to deal with increasing data consumption. That's it. Probably let's check what we also have. Project structure. Project structure could be presented like that. We at least need following folders like assets for everything for our Azure configs and YAMLs and JSONs and our infrastructure as the code. Our front end should be separated with the source code of the front end and build a dist folder. Our reader web API and writer API, basically the simple ASP.NET for applications, but with this command query segregation responsibility from a beginning, just because we definitely need to have a different flows for a read and for write operations. Our workers could be also hosted in Azure as web jobs or something like that. We need an identity server, separated one. Probably for that could be used some kind of identity server 4 or something similar. Also, as soon as we have a couple applications connected together, then the data contracts, data access interfaces and validation could be shared among our different applications. Proposed web app structure is like that. So we probably could have something like domain-driven design and secure REST patterns in mind. Let me actually open right here. So we could have our presentation layer in the form of web API with a set of controllers. Then these controllers will use logic in the application, and application is the heart of our solution. Here we have, for example, features and different type of features. For example, commands to create, update or delete data, and queries to consume data. So this structure fits to any kind of read API service or mutate API service. Then our persistence should be in a separate project and injected as a dependency, because we could change our mind on a persistence layer. So persistence should be injectable into the application layer in order to perform data or IO operations. Basically, that's it for the proposed solution. Let me check my notes. Yep. Out of the scope, I did not describe a message or format message or different format or different messages we send between front and backend and workers over the service bus. And also there is nothing said about testing, like a functional or performance test that could be decided later if the proposed architecture is accepted. Basically, that's it for the demo, and thank you so much.